All right, so here's video number 1 for the year. I might come back and throw a few videos in for the other stuff I've done, but finally found my camera, got the battery charged, so we're ready to go. Here's the 5.1 task. For those of you that need maybe to review or we're gone, I'm gonna refer this video to you, but I'm gonna get through this pretty quick. If you need to pause and catch up, do so. You're gonna have to do a couple of times. But you need to pay attention to what I'm going to do and what I say. There was a little bit of confusion in class. I'm sorry about that. But ask questions if you need to, because there were a lot of people that were asking questions in class too. The very first page of the task, basically what it does is it goes through and just makes some observations. And it says, hey, somebody brought up the question of, is the sum of two odd numbers always even? Well, whether you are like really curious about that or you don't really care about that, it brings up a good question that sometimes we just take things for fact when we don't really know ourselves. So if you look at this, student number 1 basically says, well, I've heard that this is true because my teacher says, and my math teacher's a genius. Student number 2 says, well, I tried some examples, and student number 3 came up with some diagrams, and student number 4 came up with some equations. Now, what's the difference between student 1, 2, 3, and 4? Well, student number 1, I mean, if you're just going to say, yeah, I think it's true because my teacher says, okay. Student number 2 and number 3, at least they came up with some sort of examples. Student 4 came up with an example, but they're way up there. They came up with some algebraic stuff, and they might understand algebraically. Some of us, most of us, me, would be student number 2 or student number 3. Well, for us today, we're going to be student number 2 or student number 3. The very first thing you need to do, and if you don't want to cut this out, just take a blank piece of paper and cut out some triangles. In class, we use the 2 smaller yellow triangles. So if you're doing this after the fact that I've given you the notes, you can cut out the 2 smaller triangles. Or if you're at home doing this, you can just cut out the 2 smaller triangles. When you cut them out, make sure you go ahead and label them. Angle 1, angle 2, and angle 3 in both triangles. Do so. Now you're going to have to pause, probably to catch up, and if you do, that's okay. So pause and catch up. And now I'm going to go to where we start experiment number 1. And what I'm going to tell you is experiment number 1 is leading us to the idea that, gee, is the sum of the 3 angles of any triangle 180 degrees? Well, I don't care which triangle you choose, all right? I have a couple of different ones. In fact, I have one right here that looks completely different, and I hope you can see this. I've got the camera to the side because I'm trying to block the light here. But you can see that this triangle is a completely different shape than this other one that I'm going to choose. Now, what I'm going to do for the experiment is I'm going to go ahead and I'm going to tear off angle 1, 2, and 3 from this triangle about the size of my thumbnail. Now please do not cut them. If you cut them, it's going to make this more difficult. I want you to tear. So tear angle 1. Notice it's about the size of my thumb, or angle 3 rather. It's about the size of my thumb. I'm going to do the same thing with angle number 1. It's about the size of my thumb. And I'm going to do the same thing with angle number 2. It's about the size of my thumb. So now I've ended up with all 3 of my angles. Right? So there's that. Now take angle number 1, and I want you to glue it, if you have a glue stick, glue it on your paper between the experiment number 1 and question number 1, because we got to answer the questions. So what I'm going to do is I'm going to go ahead and I'm going to place it on my paper here. This is representing, it's not an ice cream cone, it's representing angle number 1. So now I'm done with number 1. Angle number 2. I'm going to take angle number 2, the vertex, not the ripped part, but the vertex, the pointy part, and I'm going to place it next to number 1, either on the right side or on the left side. So if I go on the right side, and I'll use a different color here just so you can see. Hopefully you can see. That yellow is kind of hard. Here's angle number 2. So I placed it next to it, either on the right or on the left. There's angle number 2. And we're going to do the same thing with angle number 3. I'm going to put the vertice, not the rip side, I'm going to put the vertice next to it in number 3. Hopefully you can see this. And here's number 3. Now, what do we notice when we place angle 1, angle 2, and angle 3 next to each other? We should notice that angle 1, 2, and 3 should form a straight line. This is proof the sum of the 3 angles of the triangle that I have equal to 180 degrees. Now watch this triangle over here. If you're not sure about this, if this is true, I'm going to take these 3 angles. I'm going to put number 1 in space, just randomly. I can put it however I want. I'm going to take the vertice for number 2 and make sure that it matches up next to number 1. Not like this. This is not matching. It's got to be next to. And then I'm going to take vertice number 3 and I'm going to place it next to 1 or next to 2. Doesn't matter. Right here you can see it forms a straight line, or if I put it next to number 1, it forms a straight line. So what does this experiment tell me about the sum of the interior angles of the triangles you cut out? They equal 180 degrees. How does it do so? You need to explain. How did we do this? What did we do? Right? We took the angles and placed them adjacent to each other. Right? So that's what you need to write. You need to have a complete sentence. No complete sentence, no credit. Right? Now, question number 2. Since you and your classmates, now assume you would be in class, and in class there's 30 plus of us, and we all would have done this correctly. And if we all did this correctly, they should all form a straight line. So that's 30 examples, not just 1, not just 2, like the second student did, where they did a couple of examples. We did 30 plus examples. So since you and your classmates have performed the experiment several different triangles, does it guarantee that we will observe the same result for all triangles? Not just the ones we cut out, because remember, everybody had a yellow piece of paper, and everybody's yellow piece of paper, these 2 triangles were the same. But what about mine over here? Mine was completely different than the other 2 that I cut out. Did it work for that one? So it says, will it work for all triangles? Well, the answer to that is yes. Why or why not? Well, it doesn't matter what the dimensions of the triangle are. It's going to work for every triangle, right? It worked for this one. Yeah, pretty much everybody had the same one, but it also worked for that one. The dimensions of these 2 were different. Right? So there's experiment number 1. Experiment number 2. You're going to take the second triangle. Okay? You're going to take the second triangle. You're going to place it on the paper somewhere, and you're going to go ahead and draw it out. Number its angles. 1, 2, and 3. So here's my triangle. My angles are numbered 1, 2, and 3. Trace it. Don't just randomly draw like I did. You need to place this on there and trace it. Now what we're going to do with this triangle is we're going to find the midpoints of all of the 3 sides. Now how do we find the midpoints of all the 3 sides? I'm going to try and come closer here so you can see this. I'm going to take angle 1 and I'm going to fold it over, or vertice number 1, and I'm going to fold it over to vertice number 2. Now keep in mind, I want to find the midpoint of this side. It should be in the middle, right? If I fold 1 over to 2 and fold it in half, this crease inside the triangle should be in the middle. Now I want to fold 2 over to 3. So I'm going to do that. I'm going to fold it in half, and I'm going to see a crease there in the middle of this line. And then this longest line in the triangle, I need to find the midpoint of it. So I'm going to go angle 1 to angle 3, because that's the only one I haven't done yet. So angle 1 to angle 3, fold it. There we go. Now I found the midpoint of all the sides. And you might draw a little indicator on your triangle, just as I have done with my example here. So I drew the little hash mark. I indicated that with all of them. All right? So now I've done that. What do I need to do now? Well, bullet point number 1, it says you need to rotate this triangle about the midpoint of one of its sides. Well, I'm going to choose to rotate it about the middle of this side over here. So this side over here, the middle would be about here. Now pay attention to how I rotate it. Okay? Pay attention to how I rotate it. The middle of the side, not one of its vertices, but the middle of its side. If I rotate it about the middle of its side, how is it going to look? Now, I didn't trace this exact one, so this one's a little bit bigger than the other. But how does it look? It's going to look like this. Where does my numbers go? 2 and 3 should swap places, right? Because if I take a piece of string and I rotate it about the middle point, the two endpoints just switch spots, right? So 2 should go here, 3 should go here. That means 1 has no choice but to be over here. There's rotation number 1. Now it says rotated about the midpoint of one of the other two sides. Well, first of all, what shape did we create? Here we created a parallelogram. Because if this is 5, this side is 4, and this side is 3, think of where 3, 4, and 5 went. 3 stayed, 4 went down here, and 5 went over here. Opposite sides of a parallelogram are the same. Now, I'm going to rotate it again about one of its other sides. I could either rotate it about the midpoint of the bottom, which would be down here, or I could rotate it about the midpoint of the hypotenuse, which would be over here, which is what I'm going to do. Now, where do my things go? Well, I rotate it, or my vertices. I rotated it about this, so these two numbers swap. So 1 is up here, 3 is here. That means 2 has no choice but to be there. And I'm going to go ahead and I'm going to kind of clean this up a little bit. I'm going to get rid of 5. I'm going to get rid of 3. I like this. I'm doing something new today. I'm liking this. Okay, so here's my stuff. What's the whole point of this? I did 2 rotations. And what was the last experiment? The last experiment was the 3 angles in a triangle added up to 180. If you did this correctly, you should have angles 1, 2, and 3. Not in that particular order, but notice I have all of them. I have 1, 2, and 3. The sum of the 3 angles of a triangle form a straight line. That's what they form. What does this experiment reveal about the sum of the interior angles of a triangle you cut out? They equal 180 degrees. How do you know so? What did we do? After a couple of rotations, all the angles were included. Do you think you can rotate all triangles the same way about the midpoints of its sides and get the same results? Yes. Why? Again, what was the thing we discussed previously? It doesn't matter the dimensions of the triangle. Okay? It's saying, are we going to get the same results? We should. It shouldn't matter. Right? And then the last thing I want you to do, here's my paper that I did this on. Remember, I do this just as you guys do. Take the triangle that you found the midpoints of after your diagram and go ahead and glue it onto this paper. And then that's the end of the experiment. So here was experiment number 1, formed a straight line. Experiment number 2, I used colors with this one, but I've got all my angles right here. If you have numbers, that's fine. There's experiment number 2. Your task is complete.